Welcome to Networks Professionals.
Welcome to The Explainer. If you're a focused learner looking to cut through all the noise and get straight to the core of how modern artificial intelligence actually works, well, you are in exactly the right place. Today, we're looking at one of the absolutely most fascinating mechanisms driving AI breakthroughs, which is reinforcement learning. Okay, let's dive into this and decode exactly how machines are teaching themselves to master these incredibly complex tasks.
So think about this for a second. How does a machine learn without a human explicitly handing it the answer key? To really wrap our heads around this, we actually need to look at our own human experience. Just think about how a toddler learns to walk. You don't hand a 1-year-old a textbook on physics and bipedal mechanics. That'd be ridiculous, right? They just stand up, wobble around, and inevitably, they fall. That fall is their negative feedback. But when they take a step and somehow stay upright, they get positive feedback. It's a reward, like finally reaching a toy or getting a massive cheer from their parents. Through continuous trial and error, the child's brain naturally optimizes their movements. AI researchers eventually realized, hey, we could actually replicate this exact biological process inside a computer.
Section 1. Learning through trial and error.
So, the crucial point here is the actual definition of reinforcement learning, or RL for short. It's essentially an AI method completely built around optimization through consequences. There's no predetermined script here. The artificial intelligence acts, the environment pushes back, and the AI adjusts. It's this relentless, high-speed cycle of trying, failing, adapting, and ultimately succeeding. The AI has this one singular obsession: figuring out the precise sequence of actions that is going to yield the absolute highest cumulative reward over time. It doesn't just want a quick, easy win. It wants to master the entire process to maximize its overall score.
All right, moving on to Section 2, the 5 elements of RL. First up, we've got the agent. You can think of the agent as the main character of our story. This is the AI itself. It's the active decision maker in the system. Depending on what we're trying to achieve, the agent could be a physical, super complex robotic arm in a laboratory, or it could literally just be a digital character running around inside a video game. It's the entity that is actively observing, learning, and making the choices. Second is the environment. If our agent is the player, well, the environment is the board. This is the specific space where the agent operates and interacts. And just like the agent, the environment can be strictly digital, like the 64 squares of a chessboard, or it can be completely physical, like a massive, bustling fulfillment warehouse where a physical robot has to navigate. The environment contains all the rules, the boundaries, and the fundamental physics of the world the agent lives in. Element number 3 is the state. The state is really just a snapshot in time. It's the current situation or condition of the environment at any precise moment. So if our agent is playing chess, the state is the exact arrangement of all those pieces on the board at that specific turn. It's the where are we right now data that the agent uses to figure out what in the world it should do next. Fourth, we have the action. Basically, these are the actual concrete moves the agent decides to execute from its available options to alter its current state. The agent looks at the state, calculates what it can do, and takes an action. That could mean a digital chess engine moving a knight to f3, or it could mean a physical robotic arm applying just 1 extra ounce of pressure to a delicate object. Every single action fundamentally changes the environment, which creates a brand new state. And this brilliantly illustrates our 5th and final element, reward and punishment. Once our agent actually takes an action and alters the state, the environment immediately delivers feedback. And this is based strictly on whether that action brought the agent closer to its ultimate goal. Did that chess move trap the opponent's king? Amazing, here's a massive positive reward. Did that robotic arm totally crush the delicate object? Terrible, here's a severe punishment. This goal-based feedback is the invisible hand that's constantly guiding the AI toward mastery. Okay, let's get out of the lab. Section 3, RL in the real world. Reinforcement learning isn't just some abstract theory. We're going to look at 3 massive real-world applications where this trial and error learning is making huge waves right now: game AI, robotics, and autonomous driving. Let's kick it off with game AI. Because we can simulate digital environments at completely mind-boggling speeds, games are literally the perfect training ground for RL. An AI agent doesn't just play a game once. It plays millions and millions of games against itself in a matter of hours. It explores every possible move, losing points for in-game deaths or blunders, and gaining points for victories.
Through this incredibly brutal, rapid-fire trial and error, RL agents have completely mastered massively complex games like chess, Go, and those classic Atari games. In some cases, the AI has even discovered totally game-breaking glitches to maximize its score that the human developers didn't even know existed.
Next up is robotics. Now picture the tension in a robotics lab for a minute. You got this incredibly expensive, super complex robotic arm trying to pick up a really fragile item. Through reinforcement learning, this robot is learning exactly like our toddler from earlier. It attempts to grasp. If it drops the item, boom, it receives a severe digital penalty. If it applies way too much pressure, penalty. But when it finally calculates the absolute perfect angle and pressure to lift the item successfully, it gets a massive reward. Using this exact same feedback loop, robots are right now learning how to walk across uneven terrain, autonomously navigate through complex mazes, and grasp objects with real human-like dexterity.
And then we have what is probably the highest stakes application of all, autonomous driving. Out on the actual road, the rules are incredibly strict because human lives are involved. The self-driving car's AI agent is just constantly reading the state of the road. It earns its rewards for smoothly staying in the correct lanes, maintaining safe speeds, and avoiding collisions. Conversely, it is strictly and severely punished in its simulations for any accidents or erratic driving whatsoever. Over countless simulated and real-world miles, the agent optimizes its driving actions for maximum safety.
Let's move to Section 4 and see how this builds into what we call the autonomous experience.
So for a really long time, the absolute go-to method in AI was supervised learning. But the catch is, it relies super heavily on human input. It requires massive, highly curated data sets. For example, if you want a supervised learning AI to recognize a cat, humans literally have to sit down, collect, and manually label 1,000 pictures of cats, constantly telling the computer, hey, this is a cat. It is incredibly labor-intensive. Reinforcement learning, though, it totally flips this script.
Now, what's really interesting about this slide is the sheer independence of the RL system. Reinforcement learning requires absolutely zero label data from humans. None. Zero. We don't have to show it 1,000 correct moves. We just set the goal, we define the rewards and the punishments, and we just let the agent loose in the environment. The AI figures out the absolute best strategy entirely through its own autonomous experience. It learns by doing, not by being told. Which kind of brings us to this final, really thrilling thought. We've honestly just scratched the surface today. Running behind these concepts are some incredibly deep, complex algorithms like Q-learning and deep Q networks that are driving this whole autonomous experience forward. So the real question we have to ask ourselves is, now that machines can truly learn just by doing, what specific industry should AI master next? Could this exact trial and error AI design our next supermaterials, or maybe even cure diseases? Thank you so much for joining me on this explainer. Keep asking those big questions, and I'll
Thanks for watching.